In this worksheet, we're looking at calculating relative molecular mass, or as it says here, relative formula mass. You can see the symbol for it is MR, or M subscript R. That's M subscript R, or it's also relative molecular mass, okay, RMM. So this is when we're looking at the periodic table with all the cells of the different elements. So for like carbon, I think the atomic number is 6 and the mass number is 12. In this exercise, we're most interested of the two numbers, we're most interested in the mass number. So we'll be adding up the relative molecular masses of the elements in some molecules, in these molecules or these substances. So for the first one, we see this LIF. The first challenge is knowing what symbols are represented here. Is this, when I'm looking at LIF, is it 3 elements? Is it 2? Is it 1? So you need to be familiar with the periodic table. So this is lithium, Li, and fluorine. So I get the relative atomic masses, and that can be actually AR for atomic masses, and then when there's more than one atom, it becomes molecular masses. So the AR, the atomic mass of lithium, is 7, and the atomic mass of fluorine is 19. So I simply add them together, and I get 26. And MR is it's a unitless value because it's relative, but actually for doing the leaving cert chemistry, it's good to think of it as grams per mole. Okay, it's best to think of relative molecular mass in these units. It's very helpful for the calculations. So for in this example, lithium fluoride has 26 grams per mole. So we know if we've got 26 grams, well, we've got a mole, and from that kind of statement, however many grams are per mole, we can work out the number of moles in different masses, and it can also go the other way around. So the next one, C2H4. We don't need to know the names of these compounds going down here in this first column, but we do need to know which elements they are to find the atomic masses. So we've got carbon, atomic mass 12. We've got 2 of them. That's this number here. This number applies to the symbol to the left of it. So we've got 2 atoms of carbon, so multiply that by 2, and then we've got hydrogen, which has an atomic mass of 1, and I got 4 of those. So I input that into my calculator, 12 by 2 plus 1 by 4, and I get 28. Now next one, okay, so getting the hang of it so we can move a little bit quicker now. Sodium, 23, plus hydrogen, which is 1, plus carbon, which is 12, and then plus oxygen, which is 18, 16, and we've got 3 of them, so multiply that by 3, and that gives me 84 grams per mole. So these units apply to this last column here. Okay, each value in this last column is grams per mole. And we've got K. What's that? See that in the first column of the periodic table, potassium. So atomic mass 39, plus we got nitrogen, which is atomic mass 14, and then we've got oxygen, which is 16. We got 3 of those atoms, so by 3, and then we get 101 grams per mole. H2SO4, see that a lot in chemistry. That's sulfuric acid. So hydrogen is 1. We got 2 of those, 2 atoms of hydrogen. And then we got sulfur, which is 32 grams per mole. And then we got oxygen, and there's 4 atoms of oxygen, and that adds up to 98. Zinc is 65. And then this 2 applies to everything within the bracket. So we've got carbon by 2, and we've got nitrogen by 2. Oh darn, I meant to put in the atomic mass of nitrogen, not the symbol. So that's plus 14 by 2. That adds up to 117. And then we've got Al, which is aluminium. We've got 2 of those atoms, So it's 27 by 2 plus oxygen. Seeing a lot of oxygens in these substances. Oxygen, and there's 3 atoms of oxygen. So by 3, add that or input into the calculator. 102 grams per mole. Now we got calcium chloride. Calcium is 40, and we got chlorine, which is 35.5, or actually in the periodic table I'm looking at now, it's just 35. So we'll go with that, and we got 2 atoms of that. So by 2 equals 110. Depending on the periodic table you're working with, you might have slightly different figures. The might be more accurate, might have decimal places included, but in the periodic table I'm working from, there's no or very few decimal places, so just using rounded numbers for this exercise. And last one, we've got nitrogen, N14. Only 1 atom there. We got another one later on, just the way it's written. I'll add it up the way it's written. We got hydrogen, and we got 4 of those atoms. And then we got nitrogen again, 14. And then we got oxygen, and we got 3 of those atoms. And that adds up to give 80 grams per mole.